Hey, hi, hello guys, welcome back to Code with Nani Chanda. So today we're gonna discuss lead code problem of the day, which is house robbers. So which is basically house robbers 4. So there are several consecutive houses along a street, each of which has some money inside, and there is also a robber who wants to steal from the homes, but he refused to steal from adjacent homes. So let's just highlight this. So what he wants to do is he wants to rob the money inside the houses, but he refused to steal the money from adjacent homes. The capability of the robber is the maximum amount of money he steals from one house of all the houses he robbed. Okay, you are given an integer array nums representing how much money is stashed in each house. Normally, the ith house from the left has nums of $5. You're also given integer k. Return the minimum number of houses the robber will steal from. It is possible to steal at least k houses. Return the minimum capability of the robber out of all the possible ways to steal at least k houses. Okay, cool. I'll just explain you this code with an example. This question with an example will clarity. So what they are saying is, so they are given a consecutive houses. This is maybe a house one. Okay, this is house two, this is house three, house four. So in each house there are a certain amount of money which is represented in the form of a array nums. So this is the amount that inside the first house, second house, third house, and fourth house. And there is also a robber. Okay, there is also a robber. So if he steals money from this house, he never chooses the adjacent house, so he may choose this house or he may choose this house. Okay, got it. So if he robbed in the first house, if he robbed in a house, he doesn't chooses the adjacent house, which is, suppose if he robbed this house, he this house, he never chooses the adjacent houses, because there might be a chance that he will be caught. So yeah, he'll never choose the adjacent house. So, and you know they also given a k variable which is k is equal to 2, which he need to rob 2 k houses, out of which we need to get the minimum value, so that he can get out of these houses. But after every visit he only holds the maximum value. Suppose what they're trying to say is, the robber will visits two houses, right? Suppose this is house 1 which has money 8, this is house 2, this has money 2. Okay, this is house 1, this is house 2. As here given k is equal to 2, so the robber will rob two houses. Okay, but he only holds the maximum amount, but robber only holds the maximum amount, which is 8. So we need to minimize this. We need, there might be, see, suppose we have a four houses. So within four houses he will only chooses two houses. That may be in any case. But what we need to do is, we need to return the minimum value of minimum value of out of all the possibilities. So in each possibility he'll pick the maximum amount, but out of all the possibility we need to return the minimum. Okay, so in first scenario, so in first scenario, so this is 2 3 5 9, right? And k is equal to 2, right? So the robber wants to rob the two houses. So okay, so case 1, which is, at first he'll rob this house, right? He'll rob this house. So 3 comma, so if he rob this house, he cannot choose this or he cannot choose this. What is the another house? Because at the end he need to choose at least k houses, right? So you need to choose other house as well. So this is 9. So as the question says, in each robbery he only holds the maximum value of the amount, which is 9. Okay, cool. In in other scenario, in other scenario, in another scenario, he may choose this as the house, this as the house. So if he choose this as the house, he cannot choose this. Case 2, which is, if he chooses this, he cannot choose this. So which is, he then he can go for fifth house. So in this possibility 2 comma 5. In other case, same case here. If he chooses this house, he can choose this house as well as the second house, right? Correct. So in that case, what will be the value? 2 comma 9. So as in each robbery, he only picks the maximum value, which is 5, which is 9. Okay. So so we pick this one. We pick this one. Suppose if he picks this as the house, then he cannot pick this, he cannot pick this. But if he picks this, that will be the same case, 2 comma 5. Okay, so no need to check that house. And if you check for the 9 as well, so if then he cannot go for this, right? We have a case 4, which is he chose 9 as the house, but he cannot choose 5. Then he has the possibility of choosing 2 or 3. So 9 comma 2 will be one case, case 5. 9 comma 3 will be another case. As 9 comma 2 is the case, 3 is the same thing. So I'll just eliminate this. Out of 9 comma 3, what is the maximum value? Which is 9. Because in each robbery he only picks the maximum amount. But what we need to return is, we need to return the minimum value out of all the possibilities, such that the robbery will the cause of the damage for the robbery will be minimum. So that's what we need to return. So out of all this, what is the minimum value? Minimum of 9599, so which is 5. So we need to return that as answer. We need to return that as answer. Let's check the answer once. See, so 5. So that we need to return. So how do you approach this solution? So what is the intuition? So you may have any number of houses. Let's just take 5, 5 or something, 6, 5, 4, something like this. So you never know what will be the and let's say k is equal to 3 as well, because we need any value. So we need to pick 3 houses, and we need to return the minimum amount of the value. Okay, so how do you do this problem? So what's the intuition is, suppose we never know what will be the answer. So definitely the answer will lies in between 1 to max in terms of nums, right? Okay, definitely, because in the worst case, 9 will be the, in worst case, the maximum value will be the amount that will be the minimum value out of all these things. So that can be 1 to maximum value out of it. So 1 to 1 2 3 4 5 6 7 8 9. So anything will be the answer. That cool. That is cool. So so suppose if he choose something like 5, whether it is possible. So suppose he chooses a 5 as his a maximum minimum returns of it. So we need to check whether it's possible to get a 5 as well or not. So if you can able to check whether he can rob 3 houses using 5, then that will be the minimum value, right? Let's just check. Suppose he can choose this house and this house and this house. 976, 975, right? So that can be possible, right? So if we choose this particular combination of things, definitely 5 will be possible. So what we need to return? We need to return the minimum value. Suppose 5 is possible, right? Then I'm asking you a question. Do we need to check for the 6, 7, 8, or 9? Because we need to return the minimum value. We already found one value, which is 5. So even if you check for 6, 7, 8, 9, that doesn't make any sense, right? Because we already find a minimum value. Then why to check in the greater than that element, right? If we check on this left side part of the array, that will be efficient. So there may be a case this will be the answer, or else uh, any value in this left part of this array can be answered, right? So that intuition behind this problem is binary search. Suppose you find any value as a mid element, if it satisfies the condition, what we need to check? We only check the left part of the array. We don't need to check right part because we need to return the minimum value. If mid is possible, then checking the right side will lead to a maximum value. So we no point in checking on the right side part of the array. So we'll check left part of the array. Let's check. Suppose in this case, this will be the left, this will be the right. What is the mid element? Let's suppose take this as the mid element. So will 2 is possible to make any? So just take this as R. Will 2 is possible when we don't have any 2 value. So even you take any room, 2 is not possible. So if any mid value is not possible, suppose 1 2 3 4, suppose if this is not possible, then definitely even 2 is not possible, then how come 1 will be possible? So we know it doesn't make any sense to check on the left part. If mid is not possible, then just directly check for the right part. So that's what we do. So if t is not possible, left it. Now check for this particular part of the array, 3 4. So let's just take 3 as input. Even it is not possible because we don't have any house with the 3 as the input. So then let's just take the 4. Now if you pick any combination using 4, 3 houses need to be robbed, right? So you take 864, 864, or 964, or any combination with the 4, then 4 will be the answer. So 4 will be the answer. So what's the intuition? Suppose if mid is possible, then we only check on the left side part of the array. If mid is not possible, then we only check the right side part of the array. In the end, we'll just return the answer, which is the minimum out of all these combinations. So that's the intuition. I'll just dive you through the code, then you'll get clear picture on the question. So as you are following my videos from past 3 days, you definitely get used to this um, template, or you can say binary search questions, because we have been solving the same questions from the past 3 days. And if you if you solve it on the last previous 3 days, definitely you can easily solve this problem as well. So what we're trying to do is we're just initializing with L equal to 1, R equal to 1 in it. You can even do this, get the maximum value, and you can even initialize with the R. But why to just loop it again? Thus I'm just initializing with the maximum value out of it. So anyways, we are just dividing in each time, like we are dividing the array into half, right? So it doesn't take too much time, just probably 3 4 iterations more. So I'm just doing it with R equal to 9. So suppose even if you want to try, you can just put maximum, iterate through the array and get the maximum value, and reinitialize with the R as the maximum value on that particular array. I'm just initializing the answer as 0. There might be a case where nothing has been found, right? In that case, L less than or equal to R will get the mid element, which is, you can even write L plus R by 2, but I'm more into these things. But when there might be a case when L and R is 10 power 9, then adding it will lead to the outbounds of the integer. So that's why I tends to do in this way. Even it is the same thing as that. See, L plus R by 2. Suppose if it is 10 power 9 and R also 10 power 9. So 10 power 9 plus 10 power 9, which is 2 into 10 power 9, which leads to a outbound of the integer. That's why what I do is L plus R minus L by 2. So we are just subtracting. Suppose it is 10 power 9 and it is 10 power 9. So we are just subtracting. So that doesn't overflow the integer. So take this equation, L minus R by 2. So 2 into L, that is 2L plus R minus L by 2. So 2L minus L, R plus L by 2. So which is same as that equation, but in a different way of writing. Okay. And if I'll check for a mid element, whether it is possible to make that as a minimum out of all the robberies. If it is possible, I'm just storing it in the answer. And what we need to do, if mid is possible, then we don't need to check on the right side, because going on to the right side will lead to a maximum value. We need a minimum value, so we only check on the left side part of the array. Okay, that's why what we are trying to do is we are just decrement the r to the mid minus 1. Then we'll check that particular from left to mid minus 1th element. We'll check on that array whether it is possible to make any minimum value or not. Else, if it is not possible, then checking on the left side definitely will not get you the answer, because even for that mid element it is not possible to get a rob. Then definitely it will be on the right side of part of the array. That's what we do. L is equal to mid plus 1, and then we'll just return the answer. So the logic for the check function, like which checks the whether it is possible for that particular mid or not. So just initializing. So I generally tend to use this kind of lambda function, as I told you in my previous video, where like we don't need to pass the params like nums k and all, because if we write a lambda function, it's still inside the function, so which is inside the function scope. Definitely it can able to access. Suppose if you are writing a different function, we need to pass those parameters, because these variables are not accessed in that function. That's why. So yeah, I'm just this is the syntax of this lambda function, where you can write integer or bool, but you can write integer or bool, right? So this is the lambda notation, and we are passing mid as the parameter, and the return type will be the bool. So that's the syntax of this lambda function. We're just initializing with the counter as 0, as we are iterating through the nums array. If we find any element which is less than or equal to num, find any element which is less than or equal to mid, then count plus plus, and as we robbed into that house, we shouldn't rob the adjacent house. So that's why we are incrementing the again, as anyways on each iteration I will be incremented, right? So if you don't use I plus plus here, then in the next iteration next adjacent house will be visited. So to eliminate that, we are incrementing again, so that if this house is being robbed, so the next element will be robbed. So that's what we are doing. Okay, then increment it. In the end if we find the count is greater than or equal to k, which means if there is a mid, if there are a count of which is equal to mid or less than mid, and that count is equal to k, which means we can able to visit a k robber, I mean k houses for the robbery, then we can say it is possible to get that minimum value, right? So that's what we're doing. If count is greater than or equal to k, then we are good to go. So then it will return true. If count is less than k, then it will return the false, because this condition will fail, right? So in that sense it will return false. If that's the condition is satisfied, then it will return true. Let's just run the code. Let's submit it. Voila, it's submitted. And that's it for today video, guys. If you like my explanation, do subscribe to my channel and hit that bell icon so that you never miss any notification from my channel. And if you like my explanation, and if you had any queries regarding my explanation or regarding my code, do put it in the comment section, so I'll help you out, guys. And that's it for today video, guys. Thank you. Tata. Bye bye. See you tomorrow. And do comment what is the time complexity and space complexity of this solution. So as I mentioned earlier, as I in my previous videos, I used to explain about how you can debug the time complexity and space complexity. If you watch my previous video, definitely you will get to know about this time complexity and space complexity. And don't forget to put in the comment section about the solution of the time complexity of this solution. And that's it for today video, guys. Thank you. Tata. Bye bye. See you tomorrow. Bye.